Welcome to our first topic in grade 11, thermophysics. So this topic, it starts with states of matter, and then of course it talks about kinetic theory and the likes, but all the concepts such as the changes of states from solid to liquid, their names, and also the kinetic theory, also diffusion, Brownian motion. We discussed those in detail when we were doing chemistry. So we won't waste time on that. I'll assume you still have that the same knowledge. With that being said, what I'm going to do is the topic is going to be presented in this way. So the first we're supposed to look at changes of states of matter, but I'll skip this. Then I'll go to thermal properties, but here is a catch. So on changes of states of matter, I'm going just to highlight some important concepts that are only in physics, but in chemistry maybe they are not dealt with. So maybe there are two concepts that I'm going to concentrate on. Then we'll go to thermal properties, and then from there we're going to take a look at thermal expansion, and then finally we'll take a look at thermometers. So after changes of state, look at thermal properties. Thermal properties is going to be made of two parts: thermal expansion and thermometers. In this video, we're going to do change of states and thermal expansion. In the next video, we'll look at thermometers. Then we'll look at another topic which is connected to this, which is gas laws. Then we'll be done with thermophysics. Let's get started. So we talked about changes of state, but they are what are called heating curves and cooling curves. And here are some facts about cooling and heating curves. So if a curve starts from 0, like if the temperature here, or it starts from, the time is 0. Here where it starts, usually the time is 0, because as we're observing whatever process was happening, we took our stopwatch, then we started it like it was running. So usually here where our measurement starts is 0. So of course we had a device that was measuring temperature. So at each point we're recording the temperatures. So what's happening here? Oh, by the way, the point that I'm trying to arrive at is, if you have a curve that is growing like this, then it's a heating curve because the temperature keeps on increasing. But there are some curves which go down like this, starting from somewhere here, then they are going down, meaning that with time the temperature is decreasing, then that's a cooling curve. But the way to analyze them is the same. So even this, we dealt with it in chemistry. So this part here, usually it represents a change of state. So at any point where the temperature does not increase, then there's a change of state. Why? Because instead of the heat that's been added to the substance to increase the temperature of the substance, that heat is used to change the substance from one state to another. So as you can see, this part here, this substance was a solid. So as it was heated, when it reached this point, which was the melting point, because for a solid, when you're heating it, if you're going to have any change of state as the temperature increases, then it's going to be a melting point. So at the melting point, this solid changed from solid to liquid. So this part here, it existed as both a solid and a liquid. How so? Because part of it was turning into a liquid, part of it was still a solid. Then with time, as it was reaching here, most of the solid part had melted, so we had most of it as liquid. Then as we continue heating, when the temperature again starts rising, it means it is in another state. In this case, it's liquid. So the same analysis can be done here. So at this point, liquid shows change of state. So when a liquid is being heated and there's a change of state, then it is evaporation, as of course at the boiling point. So here the substance exists as a liquid and a gas, because part of it is going to turn into a gas, then part of it is going to turn into a liquid. Then after that it will be a gas. So this is how to interpret heating and cooling curves. Now there's something interesting about evaporation. So evaporation has what is called a cooling effect. when you boil water, then you leave water somewhere, that water is going to become cold. Why? Because of evaporation. Of course, some other factors, but mostly it's because of evaporation. Some other factors might be maybe the container is connected to something cold, so the heat might be moving from the liquid to that something which is cold, due to, you can think of it as diffusion, where things start to move from where they're high concentrated to where they are low, in concentration. So the liquid might have higher temperature, then the outside might have a lower temperature, so the heat might be flowing in that direction. The other way to look at it, or what we, of course, we are studying here, is or what evaporation does to a liquid. So if we have a liquid here, then we are heating it, it's evaporating. Let's say we stop heating it, then the particles, of course, they will be evaporated. So what happens here? So the particles that evaporate, which are always at the surface, they gain an increased kinetic energy. When you heat something, the kinetic energy increases. So when the kinetic energy increases, they evaporate. When they evaporate, they take that energy, the kinetic energy which was in this liquid. Since part of the kinetic energy has left the liquid, then the temperature of this liquid is going to reduce. So this is called the cooling effect of evaporation. Then there is another interesting thing about gas pressure. So the final point is this here, but we'll come to this. So let's say we have this liquid, and let's say on top here we have some gas particles. So gas pressure is just the number of gas particles that are on this, that are present per unit area. So if there are many gas particles here, it means the gas pressure is high. If they are less, then the gas pressure is low. So if you increase the gas pressure here, what happens is the liquid that is evaporating, the particles that need to evaporate, as they go up, they are going to bump into these gas particles and they will go back to the liquid. So increasing gas pressure reduces the rate of evaporation, which is the point here. Now we're going to cruise through the difference between evaporation and boiling. So evaporation and boiling, we sometimes use the terms we sometimes interchange the terms. So evaporation occurs at any temperature. So something can't be boiling, but it can be evaporating. Well, boiling occurs only at 100, at the boiling point, which is 100 degrees Celsius for water. Another difference is evaporation occurs on the surface of the liquid, the top part of the liquid, which is exposed to the atmosphere, while boiling occurs inside the liquid. That's where the bubbles are going to start from, the power of the bubbles and the likes. Then evaporation, there are no bubbles. Well, boiling, the bubbles are going to appear. Then the next concept is thermal expansion. So what is thermal expansion? When a board of something is heated, the board increases in size. It is called thermal expansion. So usually when you heat things, especially metals, they increase in size. So this is called thermal expansion. So how does thermal expansion happen? So think about it in terms of particles, as we discussed in chemistry. So when molecules get heat energy, when you heat something, the molecules get heat energy, which implies that they have an increased kinetic energy. Then they move or vibrate more. Then they need larger spaces between them. Therefore, the object will appear to expand, because the molecules that makes it up need more spaces between them. So that's why things expand when you heat them. So now gases expand more than liquids, than solids. In short, if you heat a gas, a liquid, and a solid with the same temperature, gases are going to expand more than liquid, than solids. So what's the application of this knowledge? So first, there's what is called a bimetallic strip, which most of us have used. So a bimetallic strip is just a compound bar made from two metals riveted together. Riveted is like joined, they can be welded or whatever mechanism. So when it is heated, it bends, because the metals expand differently. So we can have two different metals here. Different substances have different rate of expansion. In short, if you have different substances like copper and iron, you heat them with the same temperature, the copper might expand more than iron. That's how it is. And in this case, that's the case. Copper always expands more than iron. So when you join copper and iron like this, then you heat them, then as the two are expanding, iron is going to cover a very small distance, while copper is going to cover a big distance. So, but these points here are welded together, so they cannot separate. So how do they still stay in touch? They bend like this. So whenever you're given two metals which are like this, and if they have told you that these metals were joined after heating, just know that the outer metal, like if you look at this, it's like it's an arc or a part of a circle. So the metal that is outside expands more than the metal that is inside. So going further with the bimetallic strip, sorry, I wanted to stress another point here. So the point is this. This bimetallic strip is used as a thermostat. What is a thermostat? A thermostat is just a mechanism for keeping the temperature constant. So there are some devices like fridge, pressing iron, like this. So this is the mechanism. When you are ironing something, if the temperature goes high, the pressing iron is going to switch off for some time so that the temperature reduces. Then again, it will switch on its own. So this is the technique here. So this is the bimetallic strip. So as you are in a normal state, it will be connected to this. So this is a circuit, mean that power is passing here. So as you are ironing, the heat here increases. This increasing heat is of course heating the bimetallic strip, and this will cause the bimetallic strip to bend. Because of this circuit is not going to be complete. By that I mean the power, when it comes like this, when electricity comes like this, it reaches here, it won't be able to continue here, mean that this will be off. It's like you've switched it off, but it is automatic. So this is an application of a thermostat. The other application is rivets. So rivets are a form of nails used to hold two metal plates tightly together. So this is what a rivet is. So you get a rivet, then you heat it. So once you heat it, it will expand. When it expands, you can get the things you want to join. Then you make sure that you put it like this, because what you want to hold these two. So when you do that, you can leave it. When you leave it, with time it will cool down. When it cools, since this is not its normal state, it's like this because it has been heated. So when the temperature goes down, it will try to come back to its normal state. In an effort to do that, it will end up holding the these two bars tightly. So yeah, those are good things we can do with thermal expansion. What are some of the bad things? I'll just mention one. In railway, the rails of railway lines expand when temperature rises. The expansion can cause bending of the rails. So usually the way they are put, it's like this. There is always a gap here. The reason is to allow this to be expanding. So the two rails are held together by what is called the fish plate, but this is not even necessary. What's important is there's always a gap here to make sure that when it's a hot day, this expands. If this wasn't there, if these were connected, and then there is an increase in temperature, then in an effort to expand, they might end up bending. So these gaps are always